Assalamu alaikum. Bismillahirrahmanirrahim. University of the Punjab, Associate Degree in Arts, Science and BA BSc Part 1 Annual Exam 2021. Subject Mathematics B Course 1. Paper Vector Analysis and Mechanics. Paper Code Math B1. Time 3 hours, marks 100. Note: attempt 6 questions in all, selecting 1 question from section 1, 2 questions from section 2, 2 questions from section 3 and 1 question from section 4. Section 1. Question number 1. Find two unit vectors which make an angle of pi over 2 with both of vectors 1, minus 1, 0, 1, 0, minus 1. 2. Prove that A, B, C whole square is equal to A dot A dot B, A dot C, B dot A, B dot B, B dot C, C dot A, C dot B, C dot C. Determinant. Question number 2, 1. If RT is a vector function, show that d over dt r dash r double dash is equal to r dash r triple dash. 2. If ft is a unit vector in the direction of gt, show that f cross f bar is equal to g cross g dash over g dot g. Section 2. Question number 3, 1. The greatest resultant that two forces can have is a magnitude P and at least is of magnitude Q. Show that when they act at an angle alpha, the resultant is of magnitude under root P square cos alpha over 2 का whole square plus Q square sin alpha over 2 का whole square. 2. Three forces act perpendicularly to the sides of a triangle at their middle points and are proportional to the sides. Prove that they are in equilibrium. Question number 4, 1. The least force which will move a weight up an inclined plane is of magnitude P. Show that the least force acting parallel to the plane which will move the weight upwards is P under root 1 plus mu ka square, where mu is the coefficient of friction. 2. A uniform rod of length 2a and weight w rests with its middle point upon a rough horizontal cylinder whose axis is perpendicular to the rod. Show that the greatest weight that can be attached to one end of the rod without sliding it off the cylinder is b lambda over a minus b lambda, capital W, where b is the radius of the cylinder and lambda the angle of friction. Question number 5, 1. A weightless tripod consisting of 3 legs of equal length L, smoothly jointed at the vertex, stands on a smooth horizontal plane. A weight capital W hangs from the apex. The tripod is prevented from collapsing by 3 inextensible strings, each of length L over 2, joining the middle points of the legs. Show that the tension in each string is under root 2 W over 3 under root 3. 2. A uniform rod of length 2a rests in equilibrium against a smooth vertical wall and upon a smooth peg at a distance small b from the wall. Show that, in the position of equilibrium, the rod is inclined to the wall at an angle sine inverse b over a whole power 1 over 2. Question number 6, 1. Find C dot G of a uniform hollow rod circular cone. 2. Prove that the center of gravity of a tetrahedron of height h is 3 over 4 h from the vertex. Page 1 of 2. Page turnover. Section 3. Question number 7, 1. Find the radial and the transverse components of the acceleration of particle moving on the circle x square plus y square is equal to a square with constant angular velocity c. 2. A particle is moving along the parabola x square is equal to 4ay with constant speed v. Determine the tangential and normal components of its acceleration when it reaches the point whose abscissa is under root 5a. Question number 8, 1. Define projectile and find the velocity of a projectile at an instant t. 2. A projectile is launched at angle alpha from a cliff of height capital H above sea level. If it falls into the sea at a distance d from the base of the cliff, prove that capital H plus d square tangent alpha का whole square over 4h minus d tangent alpha. Question number 9, 1. Proof that the force field F is equal to y square minus 2xyz square I plus 3 plus 2xy minus x square z square j plus 6z cube minus 3x square yz square k is conservative and determine its potential. 2. Show that F is equal to minus kr is conservative and find the potential energy of the particle moving in field of force capital F. Question number 10.1. Discuss the motion of a particle moving starts in a straight line. If it starts from rest at a distance a, alpha from a point O and moves with an acceleration equal to mu times the distance from O. 2. A particle is projected vertically upwards with a velocity under root 2gh and another is let fall from a height h at the same time. Find the height of the point where they meet each other. Section 4. Question number 11.1. Define apse and apsidal distance. Derive the differential equation of a central orbit in parallel form. 2. The law of force is capital M mu 5 and a particle is projected from an apse at a distance alpha. Find the orbit when the velocity of projection is under root m over a square. Question number 12.1. An imperfectly elastic ball is projected with velocity under root gh at angle alpha with the horizon, so that it strikes a vertical wall distance c from the point of projection, and returns to the point of projection. Show that the coefficient of restitution between the ball and the wall is c over h sin 2 alpha minus c. 2. Two equal elastic spheres are laying in contact on smooth table and a third equal ball moving along their common tangent strikes them simultaneously. Proof that 3 over 5, 1 minus e square of its kinetic energy is lost by impact, e being the coefficient of restitution. Page 2 of 2.